Finite theory of the universe, dark matter disproof, and faster than light speed. We have here many scientists who observe motion through ether, not to mention the countless amount of scientists who already observed tunneling effects, all disproving special relativity. Then the question is, why do we still use special relativity in research? I will present you my theory by first showing the differences between special relativity and finite theory. I will then show what finite theory is and how it is able to make predictions as general relativity cannot do. Firstly, as we all know, ether was first proposed by Fresnel in the 19th century. It was viewed as a uniformly distributed substance that is static and by which planets are traveling through. It was later shown by the Michelson-Morley experiment that ether could not be detected. Albert Einstein went on saying that there was absolutely nothing present and based special relativity on this assumption. Now we have both extremes. What could be any different from these two possibilities? Finite theory concedes ether to be actually the sum of the gravitational potential of all masses. It also has the same spin of the emitting body. In other words, gravity is considered to be a particle and therefore unifies well with quantum mechanics. The spin explains why the Michelson-Morley experiment hardly detected ether on the surface of the Earth. Secondly, special relativity considers the reference frames to be relative. This means if we have a spaceship traveling at speed c minus epsilon and emits a beam of light going in the same direction, it will be observed to travel at speed c. Furthermore, if it emits a beam of light traveling in the opposite direction, it will be observed to travel at speed c as well. The difference with finite theory lies in that the reference frame is actually absolute. In other words, the speed of the light beam traveling the same direction of the spaceship will also be seen to be c. But if it is sent in the opposite direction, the observed speed will be infinite. Thirdly, if we go at high altitudes, then we will see the two theories to be divergent. The inflection point is actually that of geostationary satellites. In our example, the increase in altitude is actually heading towards the Sun, and therefore we see a linear decrease of the time dilation factor. But if it was heading in the opposite direction of the Sun, then we will see a linear increase of the time dilation factor. If we want to go further, we will have to conclude that both postulates of special relativity are actually wrong. Finite theory offers alternate solution where the time dilation is the product of the kinetic energy relative to its maxima and the superposed gravitational potential. The latter is what we show here. The theory is deductive. How is finite theory represented? The time dilation outside a sphere is in big part how it is represented. Indeed, since an inertial body being subject to a specific gravitational force is responsible for gravitational time dilation, and that gravity is a superposable force, we will translate the same conditions of all gravitational potentials into the sum of all surrounding fields of an observed clock and the observer. Finite theory wouldn't go anywhere without first going through what was predicted by general relativity as far as the Perihelion Precession disparity is concerned. So I wrote a simulator to get some estimates, and I was surprised to see constant results which were similar to what is observed. This is a great discovery. My calculations rely on a constant scaling factor across the solar system, and after some adjustments that needs to be done once, I get the following results. Mercury 5 times 10 to the minus 7 radian per cycle, Venus 1.8 times 10 to the minus 7 radian per cycle, the Earth 1.3 times 10 to the minus 7 radian per cycle. And the disparity was also observed for gravitational light bending, but I do not have numbers yet. One of the most practical and interesting goals in any research area in this field is the reach exoplanets. Unfortunately, since general relativity disallows any probe or ship traveling faster than 300 times 10 to the 6 meters per second, we reach an impasse because one of the closest stars, Alpha Centauri, is about 4.3 light years or 4 times 10 to the 16 meters away from us. This means light rays will take 4.36507,646 years to overtake that distance according to general relativity. Finite theory is distinct in that it predicts natural faster than light speeds. This means the time it'll take for a photon to travel between two planets, two stars, or two galaxies is given by the following equation, where h represents the gravitational potential of the universe at a given scale. For example, if we were to send a message between Alpha Centauri and the Earth, the photon will take approximately 4.3650764 years to cross over. This is 100.00001% faster than what is predicted by general relativity, which is not tremendous, but the experiment remains at a very low interstellar scale. On the other hand, if we were to send a message between Andromeda and the Milky Way, the photon will take approximately 2.5 times 10 to the 6 years to cross over. This is 100.5% faster than what is predicted by general relativity. So we see that this difference will be even greater for more distant galaxies. But we must beware because given this, a light year cannot be used as a measurement unit anymore. But the question is, since the speed of light is not constant in nature, why not manipulate it? Effectively, by creating a tunnel with a lower gravitational potential, we will observe beams of light traveling faster than light for an observer outside of the tunnel. In the following case, we reach infinite speed for a spaceship in a tunnel with a null gravitational potential. But finite theory stands apart because it is able to predict the galactic rotation curve where general relativity can't without the use of dark matter. This idea of dark matter is to replace the missing matter necessary to withhold all tangential galaxies within their cluster traveling at much higher velocities than the necessary escape velocity. Dark matter explains also the same scenario at lower scales where tangential stars should technically easily escape the attraction towards the center of their galaxy. Unfortunately, after many attempts of unfolding the nature of dark matter, no conclusive discovery can be revealed. So we see here the necessary velocity our Sun needs having in order to maintain its orbit around the center of the Milky Way, according to Newton. In contrast, by using finite theory as a mathematical representation, we will find much different conclusions. Indeed, the stars and galaxies rotating around their galaxies and clusters respectively will be subject to time contraction. This means the body will be seen to travel much faster than the anticipated Newtonian speed. There is therefore no need for any dark matter to increase the gravity strength necessary to keep the tangential objects in an uninterrupted cycle. The galactic rotation curve is given by the following equation, where h is the scaling factor of the cluster the galaxies reside in our example, and r is the position of the observer, or the distance of the sun from the center of the Milky Way. For normal galaxies, we will have the following curve. This is the same pattern as to what is being observed, but it is important to mention this is merely an approximation, since the distribution of the mass of the galaxy is not respected, and thus we have a slight difference with the observations. What about low surface brightness galaxies that are observed to have different curve? Finite theory can account for those galaxies by simply lowering the scaling factor of the cluster. This will give us the following curve, which once again matches the observations. The composition of a black hole, a question still unanswered, is solved here. But first I would like to point out that the Schwarzschild radius is solved differently according to finite theory. We can find more about its explanation in my paper, where I show that it can be found by equating the maximum kinetic energy of a photon can have with its gravitational potential. The mass of the photon is of non-importance because it is simplified. Thus we have the same equation using different methods. So if I take the smallest black hole that can be created, or the black hole created by a proton, we will have the following radius. Once again, since nothing can cross the even horizon according to finite theory, the layers of mass can only be accumulated over this even horizon. This means that 2.5 times 10 to the minus 54 meters is the maximum compression matter can reach. If we compare that with the radius of a proton of 8 times 10 to the minus 16 meters, which is another maximum compression matter can reach, we will see that matter will never be able to reach the compression of a black hole. Therefore, a black hole by its definition can never exist. Only a close-by counterpart made up of very unstable subatomic particles can exist according to finite theory. Here I disprove dark energy. Firstly, as we know, the Hubble's law is given by the following equation. This is a straight line with a specific slope. If we use finite theory in the case where the universe is not encompassed by any greater entity, then the observed speed of the galaxies minus the speed we are actually traveling is given by the following equation. This equation is the same as the Hubble's law. By equating both equations, we can easily find the center of the universe given the speed of the observer, or the Milky Way. This means if the universe has no velocity, then the speed of the Milky Way is 600 kilometers per second, which means the position of the center of the universe is minus 2.66 times 10 to the 23 meters. This is right outside the Virgo cluster we are located in, and thus this doesn't make sense. This would imply the universe itself must have a velocity of its own if we want the kernel to be farther away. The two equations will give us the following plot. Visually speaking, the universe will look like the following, having outer galaxies traveling away faster than inner ones. The question is if the kernel of the universe we see on the left is really part of the visible universe. It most likely is not because of the following reasons. First, within the visible universe we cannot see an entity bigger than a galaxy. Second, according to my last estimate, the visible universe must have a velocity relative to a greater universe. Otherwise, the center of the universe is next to our cluster. And third, given that the scaling factor h of the Milky Way is around 7 times 10 to the 26 kilogram per meter, and that for the Virgo cluster it is around 5 times 10 to the 23 kilogram per meter, it's still so high that most likely it won't be null at the scale of the Virgo supercluster. This means the universe is encompassed by a greater entity. Here, I've shown you 3 reasons to believe the visible universe is part of a greater one. This concludes my theory. It was shown that finite theory can not only replace general relativity, but really stands out by predicting the constitution of a black hole, the GPS time dilation, the gravitational light bending, the Perihelion Precession disparity for all planets, the galactic rotation curve for all galaxies, and the Hubble's law. The core mathematics can be used for measurements of the gravitational time dilation with much greater accuracy than what we've accomplished so far. But most importantly, given that gravity is considered to be a particle, controlling it is encouraged in order to build a faster than light tunneling effect completely artificially. We see here a website where we can find the simulator I used to compute the Perihelion Precession disparity and the gravitational light bending. We also see a book where we can find more details about the calculations and an example of the inside the sphere gravitational light bending. For any questions, please send me an email at the following address and I will be happy answering them. Thank you.